Alright, so this question is very simple, straightforward. You do it already. The ball is thrown upwards in the top of the building with an initial speed of 20 meters per second. The building is 40 meters high, and the ball just misses the edge of the building roof on its way down, as shown below. So the diagram that we're talking about is this. Then in this case, they've already specified to say G has to be 10. It's not a mandate that you should always be taking G to be 10, unless if they specify say G has to be equal to 10. The effect of air resistance may be negative. No need of considering the air resistance. Like we said already, to say acceleration due to gravity is the only force which is acting on this. When it has been projected upwards, acceleration due to gravity, G, has to be negative. If it was to be projected downwards, we're supposed to take that one to be positive. The first question says, how long does it take to reach its highest point? They're talking about the time it will take to move from here up to the highest point which is there. That's the meaning of how long, isn't it? Okay, so when moving from this given point to that given point, what things are you supposed to consider before you start doing your calculations? One, you have to know to say what initial velocity have you been given and what is the final velocity on the maximum point. Of course, here the final velocity is always taken to be 0. The initial velocity on this part is given as 20 meters per second. What do you do for you to come up with the time to move from here up to the maximum point? Or what you have to do is you use an appropriate formula which is written like V final, it has to be equal to the initial velocity plus acceleration multiplied by t. So since we are dealing with free-fall motion, where acceleration must be acceleration due to gravity, on the maximum point there, final velocity is taken to be 0, meaning that I'll write V is equal to 0, comma, acceleration has to be equal to G. And based on the two conditions, we said when you're moving upwards, G has to be negative. When you're moving downwards, G is supposed to be what? Positive. So in this case, our acceleration has to be negative G. When you happen to plug in this and that into the formula, you notice that we are going to have 0 equal to the initial velocity minus G multiplied by the t. Take this to the other side, it will give you G t equal to the initial velocity. Then time itself has to be calculated using the initial over the gravitational acceleration. Let's try to plug in the numbers that we have. Initial velocity is equal to 20. Then the G itself has to be equal to 10. So T is equal to 20 over 10. And our time to move from this point to the maximum point is 2 seconds. Alright, so we have to get the height from here up to the peak point. Of course, I think this has to be exactly the same as the second type of free-fall motion, whereby a particle has been projected from the ground and it also lands the same level ground. So for us to get the height which is here, all what we can do is we'll take this one to be in a simple way. Let me try to take this one to be a y. I'll just consider it to be a y. I'm making a video and making noise. Okay, I'll take this one to be a y. When I take this one to be a y, the thing that you need to understand is the formula I'm going to use to calculate for the same height will just be straightforward. I'll say y is equal to v initial multiplied by t. Then I'll say plus 1 over 2 a t squared. But of course, acceleration has to be negative. Why? Because a particle has been projected upwards initially. We expect this one to be negative g. So the height which is on top there has to be equal to, here we are going to take it to be the initial velocity and the time minus 1 over 2 g squared. Okay. Remember I said when plugging in here, we're supposed to use the total time. But in this case, we just take the time it takes for it to move from here up to somewhere there, due to one reason. Because total time in this case is a time it will take to move all the way up to that given point. So for you to get the height which is here, from the first question there, we had to take the time to be 2. So meaning that our y, which is the height it will take to move from the point of this, that given part has to be 20, time is 2, minus 1 over 2, then here we have 10, on time we have 2 squared. So our height has to be, in this case this is 40 minus, if you try to do it like this into that, it will be 5. Of course 2 squared just to give us something like 4. Meaning that the height itself, if you try to punch this on a calculator, will give us something like 20 meters. That is